The viral headline claims Apple is charging you to use Siri, framing it as a consumer pricing controversy or a new subscription trap. The engineering reality is far more significant and applies directly to your codebase. This signal confirms the end of the infinite cloud compute assumption in application development. By monetizing heavy inference tasks, Apple has physically defined the boundary between local edge processing and server-side computation. This forces developers to abandon architectures built on cheap API calls or unlimited GPU clusters. Instead, you must now design systems where every token generated justifies its cost against a hard ceiling, treating cloud inference as a finite resource rather than an infinite utility. For years, the prevailing mindset in software engineering was simple: build fast, scale later. We assumed that if we needed more processing power for AI tasks, we could simply spin up another server or call a massive API endpoint without worrying about the immediate economic friction per user interaction. The cost of running these models seemed to drop towards zero as efficiency improved, leading many teams to design applications where heavy lifting was offloaded to the cloud by default. This approach worked when compute costs were low and scalable. However, that era is over. When a major platform like Apple introduces pricing signals for AI features, it acts as a hard stop on the assumption that cloud inference will remain perpetually cheap or unlimited for end users. The new engineering mandate requires you to treat every API call and token generation as a line item with a tangible cost ceiling. Systems must now prioritize local inference for high-frequency tasks to avoid hitting the pricing cliff of cloud compute. This shift is not just about saving money, it changes how we architect reliability and trust in software systems. Generative AI has reduced the cost of producing expert artifacts like Siri responses to near zero. In traditional markets where high effort signaled quality, this collapse of production costs also collapsed market signals for value. When making something cheap becomes easy, the only way to separate a high-quality provider from low-effort generators is through liability backed by verifiable performance constraints. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This creates a new vulnerability known as algorithmic collusion in pricing models. Theoretical modeling shows that when an algorithm's output fidelity exceeds a critical threshold, systems can shift from competitive pricing to coordinated supercompetitive outcomes regardless of seller intent. This means that simply building an efficient model is not enough for your application's viability. You must design systems that avoid these algorithmic traps or risk being priced out of the market by automated coordination mechanisms inherent in shared infrastructure. In practical terms, this implies that standard engineering practices like increasing training batch sizes to improve efficiency might inadvertently lock your app into expensive pricing dynamics without you realizing it until revenue drops significantly. The data on how AI influences decision-making and value perception supports this shift toward cost-aware architecture. Studies indicate that when an algorithmic capability shock occurs, the high-type premium, the extra value a superior system commands, collapses from 20% of transaction value to zero if only production signals are used. Furthermore, participation by high-competence providers drops significantly in the absence of liability contracts following such shocks. These statistics highlight a stark reality. Without engineering proxies for reliability and cost control, your application loses its competitive edge instantly. You cannot rely on raw performance metrics anymore. You must prove that your system can handle costs efficiently under real-world conditions. Consider the odds of users engaging with an AI feature when they perceive it as authoritative versus one where the cost is opaque or unpredictable. Research shows that the odds of forgoing a guaranteed reward increased by a factor of 3.39 when AI was perceived as having uncontrolled authority, and earnings were reduced between 10.7% and 42.9% due to the influence of AI predictions on decision-making in these contexts. This reduction occurs because users and developers alike begin to view unreliable or expensive inference not just as a technical glitch, but as a financial liability. If your model hallucinates during an expensive cloud call, that cost is realized immediately by both you and the user, unlike local processing where failure might only manifest as latency without direct monetary loss per interaction. This reliability paradox forces developers to treat inference as a high-stakes problem from day one. In pricing models where AI signals can randomly reflect valuation versus true value, keeping unreliable private signals hidden yields better economic outcomes than sharing them publicly. Apple's approach effectively forces the industry to recognize that if you cannot guarantee performance or liability contracts within your code architecture, your application will face market exclusion. The assumption that cloud compute is infinite and cheap has been replaced by a hard economic ceiling where every inference carries a tangible cost. This dictates how future AI applications are built, tested, and deployed in production environments. Developers must now design for this new reality by implementing local inference first for high-frequency tasks to stay within the free or low-cost boundary of edge hardware. Only complex queries that demand server-side power should be routed through expensive cloud channels, and even then, they require strict cost controls built into the application logic. You are no longer just writing code, you are managing a financial asset class where reliability is directly correlated with economic viability. The engineering trade-off has shifted from speed of deployment to efficiency per token, ensuring that every interaction your system generates adds value without triggering prohibitive costs or algorithmic pricing traps. The path forward requires abandoning the free compute fallacy and embracing cost-aware architecture as a core design principle. Every line of code that triggers an AI inference must be audited for its economic impact, just as it is for security and performance. By understanding these structural implications, you can build applications that survive in this new landscape where physical limits and economic ceilings define what is possible. This shift marks the transition from experimental prototyping to robust engineering practice in the age of constrained compute resources. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.